Well, hello and welcome back. Today we're going to be looking at basically the last real world example problem in Chapter 3, Lesson 4 for Math and Focus 6, Textbook A. I want to just show you how to think about it a couple of different ways and how maybe you could use drawings to your advantage, which is a little bit more in depth than what the book shows you. So I think that you might be able to utilize some of this information in the future and perhaps on your test. So let's go ahead and get started. Stephen is using 2/3 of his garden to plant tomatoes and another 1/9 of it to plant lettuce. Then he divides the rest of the garden into several small plots of land, the area of each being 1/8 the area of the entire garden. So when you strike on any problem that you are asked to solve, the very first thing you need to know is it's try and understand what it is that you're looking at, right? So that means you need to ask yourself what you know. And so what do you know? Well, you know Stephen is planting tomatoes and he's planting lettuce in his garden. And he has some left over that are small plots of apparently unused land. And there are some measurements here. 2/3, in fact, of the garden is tomatoes. 1/9 of the garden is lettuce. And each of the small plots is 1/18 of the total area. But there's more than one of these. We just don't know how many. So I want to ask you to do two things. The first thing I would like you to do is to try and sketch out a picture in your brain about what this might look like if you looked at the garden from above. And the second thing I want you to ask yourself is, how are these denominators related? Is there any relationship at all between the thirds, the ninths, and the 18ths that you might be able to use to your advantage in this particular drawing? When a problem in Singapore math is friendly to drawings, very often you'll have friendly numbers to go along with it. So think about how these numbers are friendly to each other and if you can use that to your advantage. Go ahead and pause the video if you like. Do that and then come back to me. Well, here is what the drawing in the book looks like. And I want you to note that the garden, we were given this idea that 2/3 of the garden is tomatoes. So you see the tomatoes over here. And if we just mark off the section of tomatoes as 2/3, I'll put a T over it, right? This is going to be 2/3, 1/3 here and 1/3 here. And then this piece over here, this is lettuce. And we were told that that's 1/9. Okay. And then we have some small plots of land. We don't know how many. And they're 1/18 of the total area each. Okay. So something that I'm going to do to help explain the meaning to myself is to go ahead and subdivide this into ninths that the lettuce is, okay? And so I have thirds. I know that thirds and ninths are related, so I'm going to go ahead and subdivide that, right? And now I see I have 9 pieces in this garden, kind of like a tic-tac-toe board. And this lettuce happens to be a 1/9 of it. That's just this piece right here, all right? Doesn't include the whole thing like these thirds do that we just looked at. Like here's the third, the whole column, right? This 9th is only one of these boxes. Okay, so then that means that the last number here is 18ths. And how are 9ths and 18ths related? Well, you have seen this before, right? When we've taken a bar model and we have kind of carved it up to look a little bit more closely at something. And we're going to do that right now. All right. So When I'm dealing with bar models and it's an odd number, I like to put a piece, the odd number piece in the middle. I stick it there first, and then I evenly divide each side of that piece. So we're talking about ninths, so I'm going to put one of those ninths in the middle. And then if I put 4 pieces on each side, 4 and 4 is 8. So altogether that should be 9 boxes. So that's how I do our odd number bar models. You'll see me do that often, just to help explain the meaning to myself. And I'm not satisfied with actually one of those was kind of wonky looking. Doesn't have to be perfect, but I like for it to be, usable. Let's go ahead and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Lo and behold, 9 ninths, right? Wonderful. How do I turn them into 18ths? Well, if you said to divide each box in 2, you would be correct. So I'm going to go ahead and divide each box in 2. All right. And now, hopefully I'll get my whiteboard back and it will be intact when it comes back. I keep losing my connection for whatever reason. And here we go. We will see that there are 18 of these squares. Let's count by 2s just to make it efficient on ourselves. Oops. I'm going to have to need my pointer here. All right. 2, 4, 6, 8, 10, 12, 14, 16, 18. You see, in fact, that by subdividing this bar of 9, cutting them each in half, I wound up with 18. So I'm going to do that with this garden. I'm going to subdivide each of these pieces in 2. And now I'm going to go alongside the bottom of each, and I'm going to count. Let me give it a different color so you can see what I'm doing. I'm just going to count and make sure that I do in fact have 18 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, you know what? There were 6 per row and there were 3 rows. 6 times 3 is 18. Either way I do it, I get 18 pieces. So if each of the small plots is 1/18 each, right? And I've just put 18 pieces on my entire garden, I can see that there are 4 small plots. Now, I have not actually seen what the question to this particular problem is yet, right? I'm looking at just the drawing and I'm seeing what do I know from the drawing. And what I know is that there are these pieces, right? These plots. Once I've divided the garden from thirds to ninths to 18ths, I see that the vacant land seems to be 4/18, right? Of the whole. But that's just something that I have discovered in my what do I know sequence of asking myself things. So let's go to the next slide and see what we see in terms of the questions. Well, one of the questions is, how many small plots of land are there? And I just answered that, 4. Just by looking at my picture, right? So then the next one is the total area of Stephen's garden is 90 square yards. So the entire area, this whole thing, is 90 square yards. And given that, what is the area of each small plot of land? Well, I know that each small plot of land is 1/18 of the area of the entire garden. I was given that in the problem. So 1/18 of 90. What is 1/18 of 90? Remember, of... when you see that number, what operation do you think of? Multiplication, correct. So I am going to multiply 90 by 1/18. I want to know what is 1/18 of 90. Well, you know that I prefer to simplify, and I see some interesting things. I'm going to put 90 over 1, just like 18 is under 1. And I see there are 10 nines in 90. There are 10 of them. And I know there are 2 in 18. So if I multiply across, 1 times 10 is 10. 2 times 1 is 2. 10 halves is the same as 5. And in this case, 5 yards squared. So this is my answer to that question. What is the area of each small plot of land? All right. So we're done. But what if, in fact, we had no visual to go on? We could not get a visual of the garden in our head to save our lives. We just couldn't do it. Well, is there a way to solve this without having the visual? And the answer is, of course there is. We can do this without having the visual. So let's start with the one we just solved, since it's fresh in our minds. We were told that each small plot of land is 1/18 the area of the entire garden, and that was 90 square yards. Well, if we have 90 and we divide it into 18 pieces, the answer we get is 5, and this would be 5 yards squared. All right. Now you can check my math. 5 times 18 is the same as 5 times 20 minus 2 5s, right? Because 18 is 2 away from 20. So 5 times 20 I know is 100. And if I subtract 2 5s, that's subtracting 10, that's 90. So that checks out. The other way I could do it is by partial products. I could say 5 times 10 is 50, and 5 times 8 is 40, and 50 and 40 is 90. I know that as well. So either way, it works out. It's 5 yards squared, and that's a way to do it. Now, there's another way to do the first question. You remember that I did the first question all visually, right? Just looking at the picture. But there is another way to do this, right? And so it's like this. Stephen has one garden. And in that garden, there is 2/3 of it planted in tomatoes and 1/9 of it planted in lettuce. And so if I subtract the tomatoes and the lettuce from the whole garden, I will be left with the area of the small plots. Right now, the problem with this is that I have not got like denominators here. They are not like, and they need to be like for me to add them together. So I'm going to turn my thirds into ninths by multiplying numerator and denominator by 3. 2 times 3 is 6, and 3 times 3 is 9. So now I have ninths, 6 ninths. So this is 1 minus 6 ninths plus 1/9. And of course, you know by order of operations that you're going to do what's in the parentheses first. So now our new problem is 1 minus 7 ninths. And 9 is 1. So 7 ninths is taken away from 9 ninths is going to be 2 ninths. So the portion of the garden that is small plots, vacant plots of land, is 2 ninths. And I want to know how many 1/18ths are in 2 ninths, right? How many small plots are there? So I have 2 ninths, and I'm dividing it by 1/18ths to find out how many 1/18ths are in 2 ninths. And that's how you set it up. You always put what you're dividing by second in your problem, right? So you know the routine now. You're going to keep the 2 ninths as they are. You're going to change the division to a multiplication, and you are going to flip the 1/18th to be the reciprocal, which is 18, just 18. And we can put it over 1 just because whole numbers are always over 1. All right. So now I'm going to actually simplify, because as you know, it makes my life so much easier. There's 1 9 and 9. There are 2 9s and 18. And now I'm multiplying across. 2 times 2 is 4. 1 times 1 is 1. My answer is 4. 4 small plots. Okay, so either way you do it, either doing it by the visual as we did over here, and you saw that there were 4 of them, or doing it mathematically as we did right here, you also saw that there were 4 of them. And then 2 ways to figure out what the area of each small plot is. You can do them, solve these problems either way, any way that makes sense to you. That'll work. All right, that's all I have for this problem. We'll see you on the other side.